Hi everyone, Dr. Hall here. Continuing on, we're now going to talk about breast physiology, so actual function of the breasts. So the first thing to talk about is development. So certainly before puberty, male and female bodied people generally look typically the same in terms of breast development, meaning there's really nothing going on. So breast gland development really doesn't start until puberty. And then because of increased levels of estrogens, remember puberty is when the hypothalamus basically turns the thermostat up and says, okay, we want to have more sex hormone floating around in the body now. Pituitary makes LH and FSH, gets the gonads going. So the theca cells, right, start hormone production and all the things that go with the menstrual cycle that we did last week. And this estrogen now is going to stimulate the mammary glands to develop. So you can see in this upper right diagram how, we start off with there's really nothing there, and then this kind of branching tree of mammary glands and the ducts, the lactiferous ducts and lactiferous sinuses develop, as well as adipose tissue starts being deposited in the breasts, right, giving them their shape and size. So this all happens, it starts during puberty and continues for about a good 10 years or so until it's fully kind of developed and mature as far as it can go, but it's still not fully developed and mature. I misspoke. Because actually, it requires the very high levels of hormones that occur during pregnancy and then childbirth in order for the breast tissue to fully mature and reach its final mature state. So that's going to become important when we talk about breast cancer. So it's really important that full maturation of the breast does not occur until puberty and then pregnancy and then childbirth occurs. So breasts are kind of in an immature state until somebody has been pregnant and given birth. That's important. So what this image here is showing is kind of those different stages that occur over time. And they're showing them to you all in one breast just for comparison's sake. They're actually showing you different times in a person's life. So number one here, this is the reasonably mature but not active, right? And then you can see the next one down here, this is early pregnancy. And then look at mid-pregnancy, it's getting even larger. And then this fourth one, right here, this is a fully functioning mammary gland, okay? So this is somebody who's gone through whole pregnancy and childbirth and now is lactating, okay? So, and then what happens after you stop lactating, after you stop breastfeeding, is it regresses back to look just like it did at number one. Okay, so this is going to change over the course of somebody's life and hormonal status and pregnancy status. So what happens after birth that really gets this going? So after childbirth, the body starts making prolactin from the pituitary gland. And so I like this word because pro as a prefix means for, and lact means milk. Like you think about lactose, lactate, right? That's milk sugar, right? So the job of prolactin is to stimulate milk production. And so what we see actually in these microscopic images up top is we see in the top one, this is inactive mammary glands. There's nothing inside them. They're the dark purple things. There's nothing inside them. But then down here, what we see is each one of these is one of those dark purple things, and now it's just totally filled up with milk. Just totally filled. The milk looks pink just because of a stain they used. Each one of these, I'm not very good with my aim, is just full of milk. Okay, so the glands are really busy producing milk. So how does this happen? So when the infant nurses, when the infant suckles, that sends nerve signals to the hypothalamus, our old friend. It's in charge of practically everything. And then the hypothalamus tells the pituitary, make prolactin, so make more milk. And then so the infant nurses more, which sends more signals to the hypothalamus, which then tells the pituitary, make more prolactin, which tells the breast, make more milk. And then the baby nurses again. And so we see this reinforcing pattern where things get larger and larger and larger. And so that, you may remember, is a positive feedback mechanism, right? So it's going to build and build and build. Now, why would we need to build how much milk we're making? Well, baby is going to grow, right? So they may start out 7 pounds, 8 pounds, 12 pounds, very rarely, right? But then by the end of the first year, they're going to be more than 22 pounds. They're going to double in size, right? Which also means that they're doubling in their nutritional needs, at least. They're also growing like crazy, right? So there's a big difference in the amount of milk that a newborn infant needs compared with an 18-month toddler, for example. Now, which is probably the toddler that we see in the lower image, which is not a common image that we see in our society. So it's pretty uncommon in our culture for people to breastfeed much beyond the first year. But in many cultures, or even in many sub-communities, it can be common to breastfeed your child all the way up until the age of 5, actually. Now, of course, if you're breastfeeding or nursing somebody that long, they're also eating food. So the breast milk is not the sole source of their nutrition. But for the first 6 months, so introducing of solid foods, introduction of food at all is, aside from breast milk or formula, is not recommended for human infants before they're 5 to 6 months old. So that whole time, right, the breast milk is supplying all their nutritional needs, and so the supply needs to grow with them as they get bigger and need more. So that's one reason. The other reason is sometimes you have to feed more than one, right? So I had a friend who had triplets, and she breastfed all 3 of them and worked full-time as a police officer. I don't know how she did it, but she did, right? So we have this ability, many female-bodied people, not all, to increase milk production quite substantially in response to demand. This also explains why, if you've ever heard of the concept of a wet nurse, so that's kind of an old-fashioned thing, like if I was a noble woman and I had a baby, it's beneath me to nurse my baby, right? I must be off attending the queen or something. I don't take care of my own children, right? That doesn't happen. So they would find a peasant woman in the community who had also recently given birth, and then say, okay, now you have to breastfeed this child too. And so that person would be brought into the manor house or whatever to be the wet nurse for the noble baby as well as their own baby. Unfortunately, sometimes it would end up being at the expense of their own baby, and so there's a lot that goes into that. But oftentimes people can successfully nurse more than one infant at a time, thanks to positive feedback. Okay, there's another piece. Not only do you need to make the milk, you also need to squirt it out. So you might think, well, isn't the baby sucking it out? Well, they are a little bit, but it has to be up in those lactiferous sinuses. The baby cannot suck the milk out of the mammary glands. The ducts would just fall, they would just collapse closed. So when the baby is suckling, they're moving their tongue and their mouth against the breast, they're getting the milk out of those lactiferous sinuses. But we need to squirt the milk out of mammary glands through the lactiferous ducts into those lactiferous sinuses. And so that's called the milk ejection reflex. And so it's really cool. What happens is when the infant starts to suckle, as you know, that sends nerve signals to the hypothalamus, which we already learned about, then tells the pituitary to make prolactin to make more milk. Got that part. It also tells the pituitary to make another hormone called oxytocin. Oxytocin is a really interesting hormone. We're going to hear a lot about it in the rest of this semester. So oxytocin tells the cells that line the mammary glands to contract and to squeeze shut, and so to then squeeze out the milk that they've been making. And that's going to eject them out into the lactiferous ducts and sinuses. And so this is often called letdown. So if you've ever heard of that sensation of letdown, so what the nursing person will feel is that usually, 10, 30 seconds after the baby starts nursing, there's this kind of weird tingling sensation, and then, right, and then things start flowing. So that's the letdown or milk ejection reflex. Now, this is also a positive feedback mechanism. So as long as the baby keeps nursing, you keep squirting out the milk, right? And more, the more the baby nurses. Now, eventually the breasts are going to be empty. So usually about 10 to 15 minutes on each side, and the breasts are going to be empty. But in the meantime, right, you're just going to pump more and more, squirt more and more milk out. The interesting thing about oxytocin is it also promotes, it's sometimes called the love hormone. It promotes feelings of well-being and relaxation and emotional bonding. So this is also the hormone responsible for the afterglow after orgasm. And but it also is released during breastfeeding. And so I think this is pretty clever of evolution to give us this, because sometimes it's the middle of the night and it's the third time the baby's woken you up to breastfeed and you're really exhausted. So how nice that you get a little boost of oxytocin to make you feel a little love for that baby so you don't lose your cool. Okay. All right. So anytime the breast is stimulated, usually by the infant suckling, right, then nerve impulses travel up to the hypothalamus, which on the one hand is going to tell the prolactin or the pituitary gland to release prolactin, which is going to cause you to make more milk. And then on the other hand, it's going to cause you to make oxytocin from the pituitary, which tells the mammary glands to squirt the milk out. So we have both of these things happening, and both of them are positive feedback mechanisms, which is good because the baby's going to need more and more and more milk as it grows. So in summary, breast development begins at puberty with increasing estrogen levels and they don't fully complete maturation until after pregnancy and childbirth. For milk production and ejection, the suckling sends nerve signals to the hypothalamus, which then tells the pituitary to make prolactin, which tells the breast glands to make more milk, and oxytocin, which tells them to eject that milk. And both of those are positive feedback mechanisms. So our last section on the breast will be on benign breast disorders, 10B.